Here are the molds that I made for making our test specimens. They're made out of 1.5 inch PVC pipe. The inside diameter of the pipe is a hair over 1.5 inches. But after cutting the notches to make the two halves, and then measuring the inside diameter, it comes out almost exactly 1.5 inches. It's kind of interesting when you cut these things, they want to actually fold in on the saw blade. So here's some pieces that I cast just to see if the molds would come off. And they did very easily, so I was very pleased about that. Now, if you can see here, I cut in at an angle and made it so the inside here comes out right on the half of the circumference, so that the two pieces would want to stay together. And then I hold them in place with a rubber band and make sure they're level. And what I plan to do is have a bunch of these, fill them over the top, and then place a board on top to make sure the top and bottom are smooth. You can see how nice and smooth the bottoms were. I didn't fill the molds the whole way to the top, so but I expect the top to be that smooth when I'm all done. Now I'm setting up here to prepare to spray the inside of the molds with regular cooking anti-stick spray, which is basically a vegetable oil. You could probably wipe on vegetable oil and it would work just as well. So after I spray these and put them all together with rubber bands, we'll be ready to make some test samples. Now each one of these is labeled because each half mates directly with the other half. If you mix them up, you won't get a good seal necessarily. And I'll show you how I cut these. You may have a different way of doing it. First thing we'll need to do is to find the center of the piece. And then as a guide, so I don't forget which way to cut, so I'll cut in at this angle to come out at the dead center, the same way here, and that way the pieces will want to lock together rather than slide easily apart if you had made a straight cut. Okay, here we are at the bandsaw, and what I'm going to do is follow the little lines that I made. Now you see how that snaps closed. So the pipe wants to close up when you relieve it with a cut. Now we have to clean up the shavings. The easiest way to clean up this kind of stuff is with a soft wire brush, or wire wheel, I should say. It comes right off. And there we have a mold ready to go. Well, got to get a little more off. Okay. Here's the plan for our first set of test specimens. I have 3 sets of 7 molds set up here. And what I'm going to do is, well, I'll start over here. I'm going to mix up a batch of the basic 1.88 to 1 ratio of cement to water by weight, and fill this set of molds. Then I'm going to vibrate the table to settle it and put this on top till it sets up. Then with the remaining batch of the mix, I'm going to add foam and fill this set of molds and do the same thing with the other board. Then I'm going to add more foam and fill this set of molds. And then later we can weigh the various mixtures and see what the percent of air is. So let's see if we can do that. I saw a lump go into number 1 mold. Okay, I want to overfill these to make sure they're going to be smooth on top, and vibrate it a little bit and put our weight on top. Now we'll add some foam to the mix and fill this set here. Okay, I added 6 cups of the Drexel foam to the mix I had left in the bucket. Okay, I'm going to add some more foam and then come back and fill those. Well, I added 4 more cups of foam to the mix. Okay, we'll see tomorrow what we have. Well, it's the next day. Let's see what we have here. Well, it looks like we've had some settling, and it's not level with the top. So I had noticed a puddle of water. Here you can maybe see the stain, and I had sopped it up with a towel when I discovered it. So I don't think these are useful. Now these look better with the foam. They're level and flat. And the same here. You can see we had some larger bubbles, but I've always suspected there's just too much water in the basic mix that everyone uses. So I think I'll mix up another batch of the just basic cement water mix, but with a lesser amount of water, and see if we can come out with some level samples. I moved the samples to this plastic container. It has a cover which I'll put on, and I have a tray of water here which will keep the humidity in here at almost 100%. And the basic concrete mix samples I decided to keep as is, and I will just sand or cut the ends to make them square. I don't want to change horses in midstream here. So we'll let everything age for 4 weeks, and then we can do some sample testing. Well, 2 weeks have passed since we put our samples in here. So we have 2 weeks to go to a maximum strength cure, but I thought we might do some testing now and then see if 2 more weeks produces a stronger set. So what I need to do is these ones that are the basic mix that slumped somewhat as water drained off. I need to square up the surface of one of these so we could test it, assuming the mold will come off. Whoa. Came right off. Okay, I'm going to use a hand miter saw and square up this end, and then we can continue. Okay, I squared up the ends, and of course now it's a little shorter than the 2 inches, so I measured the length at 1.86 inches long. And we'll weigh this thing, and it comes out exactly 100 grams. Now, because it's shorter than these other samples, we'll have to multiply the weight by the 2 inches divided by the 1.86 inches, which is 1.075. So our true weight comparison will be 107.5 grams for the basic mix sample. So we'll take one of the foam samples . Okay, let's weigh this. And that's 46 grams. Okay. And let's take one of the other foam samples. It's funny, the foam seems to adhere to the mold much better than the actual basic mix. And that sample is 30 grams. Okay, I guess the next step will be to try and crush these. Let's try the highest foam content first. Wait, I think I have to move the camera. Okay. This is the lightest sample. Well, it's just crushing. There's no movement on the needle, and the sample is just falling apart. So I would say that's not very strong at all. So let's try the next sample. Well, we got some movement here. Well, at 80 psi, it has started to crumble. So maybe I need a lower range gauge. So let's try the basic mix sample next. There's 100, 200, 300, 400, 500, 600, 700, and it just fell apart here at about 750 psi. Oh, part of it fractured there. So I guess we'll let things go for 2 more weeks and see if anything gets any stronger. But perhaps I should make some samples with less air or less foam, because these particular mixes seem about useless. So there's our midway report anyway, and we'll continue on and see what we can learn. Okay, here's a summary of what we just did. We found the diameter of our samples to be 1.56 inches. The one that I trimmed to square up the end came out to 1.86 inches, so it was 7.5% short. So the area of our sample is 1.91 square inches. So the equivalent weight, if our basic mix sample had been the full 2 inches long, it would have weighed 107.5 grams, whereas it weighed 100 grams actual. The other two samples weighed 46 grams and 30 grams, respectively. Now, the volume of our standard mold that we're using is 2 inches long by times the area, which turns out to be 3.82 cubic inches. And a cubic inch is 16.39 cubic centimeters. So, and water weighs 1 gram per cubic centimeters. So our mold could hold 62.6 grams of water. So the basic mix density is at the 107.5 grams divided by the grams of water. So our basic mix is 1.72 times the density of water. Now our hydraulic press develops 2187 pounds per 1,000 psi on our gauge. So the psi rating of our sample with our standard 1.91 square inches turns out to be 1.15. So the sample psi rating is 1.15 times whatever we read on the gauge. So here's kind of a summary of what we ended up with. The density of each sample relative to the basic mix, well, of course, it's 1-to-1 for the basic mix. Sample 1A was 0.43 times the density of the basic mix, and sample 4B was 0.28. Now, relative to water, the basic mix was 1.72, sample 1A 0.73, sample 4B 0.48. So the PSI rating that we managed to get on two of the samples, the basic mix was 863 and the sample 1A was 92. Now I have a little asterisk here because in reviewing the video I noticed the upper piece of rubber was missing, and I found it laying back behind the press. So I noticed the sample had sheared along one edge, and that may be due to the rubber missing and us having a pressure point in that area. Now, just as a comparison of everything, the nominal rating of a standard concrete mix is around 3,000 psi. So we'll let everything age another 2 weeks, and then we'll break up some more samples, and I'll have to figure out a better way to attach the rubber to the press. So hang in there and we'll do some more testing.